Hello and welcome to Office Hours by Bit Gardner. My name is John Kowalski. I'm part of the marketing team here. I'd like to welcome you. Thank you for those who responded to my chat here. It seems to be some challenges, and I think it's our own firewall here. So anyway, it seems to be working okay. But anyway, Office Hours. If you're unfamiliar with this format, it is a shortened presentation, and then it's really turned over to you for questions, comments, any challenges you may be facing in your own facilities or plants. We'd love to help you out here. So we'll just do an open dialogue after the brief presentation. We are also recording this, and immediately following, you'll receive an automated link from the marketing group here, and you can listen to it down the road, grab screenshots, share it with colleagues, whatever you like. Today's topic, gloss theory and applications. We have one of our application specialists, Mr. Noah Morgan. He's going to be presenting today. And like I said, if you have any questions throughout the presentation, please jot them down in the chat box located in the bottom right-hand corner of your screen, and we'll get to them immediately following. So with that, Noah, all good? Ready to go?
All good.
Awesome.
Right.
Thank you, sir.
Hello, everybody, and thank you for joining. As John said, today we'll go over gloss theory and applications, and it's just a brief presentation. So if you have any questions about anything that comes up during the presentation, please put it in the chat, and we'll continue after the presentation with the open dialogue. So to start her off, what is gloss? So gloss is defined as the spectral reflection. And so what that is if you have incident light, in this case we have the sun here, it shines light down containing all the colors in the rainbow, and it hits the surface of an object. And once it hits that surface, a couple things happen. We have absorption. So our object here absorbs all the colors that it does not project. And then we have some scattering effects due to the pigments that create this diffused reflection, and this gives us the color of the object. And then pure white light is then reflected off of the surface of the object, and that is our spectral reflection, or our gloss value. So to simple it down, our gloss is simply the white light that gets reflected off of the surface of the object at the opposite angle that the light is coming from. So how is gloss perceived? So gloss is perceived with three different objects. So we have our illumination, we have our surface or object, and then we have our observer. Without one of these functions, we're unable to view or observe gloss. When gloss comes down, it comes from our illuminated source, and it is at the opposite angle that the light source is coming from. So if our light source is coming from, in this case, 45 degrees, it's reflected off the surface at 45 degrees. So how is a glossy surface perceived? So on a glossy surface, we can imagine the surface almost being completely smooth. It doesn't have any defects in it. And so what's going to happen is as that light source hits that surface and gets reflected back towards our observer or our eye, we're going to see a very clear image of what that reflected image is. And so we can say that that surface would then have a good image forming quality to it. And this picture up here on the top right kind of goes over that. And so you can imagine this as that reflected image on that high gloss surface. We see a very clear outline. The lines are very detailed. We can see a lot of structure in here. And so what that is we have a great image of what that reflected light source is, and that's due to the glossy surface. Now, if we looked at a matte surface, we have something else going on. So we see now that that image forming quality is very poor. We don't see clear lines anymore. And the reason for this is because as that light source is hitting the surface, this is a very matte surface, so we can imagine that has many micro textures in it. And these micro textures affect the light hitting the surface because they're now scattering the light in different directions. We see that the main focal point is still going towards the observer, but we're still losing a lot of light due to those scattering effects of that microtexture. And so that equals us getting this poor image forming quality from that surface. So something I wanted to touch on is the internals of these gloss meters. It's not just as simple as a light source and a detector in the instrument. There's a lot of other components that are very precise within the instrument itself. So not only do you have your light source and your detector, but these two components need to be a certain distance from each other. They need to follow the same angle with a very tight tolerance according to international standards. With this light source, you need to have a specific sized aperture, and same with the detector, that only allows a specified amount of light to pass through that hole, which then goes to a lens, which the lens then focuses all that light to a certain spot. And then on the same end with the detector, when that light comes back, it needs to hit this lens and go through that defined aperture again. So it's not as simple as just a light source and a detector inside these instruments. There's a lot of other precise components that make this instrument very accurate and can prove to be very vital in getting these types of gloss measurements. So I just wanted to go over that briefly. Now, across most industries, there's 3 standard gloss angles for measuring gloss. But then you also have some other industries like the paper industry, the ceramic industry, and the ink industry that use some special angles like 45 and 75 degrees. But for the most part, the 3 main angles are 20, 60, and 85. And we'll go over later on about when to use which angle and why. And so here we have a great case study that was done and some data that went with that, which shows you when to use which angle. So to understand this a little more, across the bottom on the x-axis, we have 13 different samples. And each of those samples varies in gloss by the same amount. So you can say, sample 4 is, looks a certain way visually. And then sample 5 is 1 step up in gloss from that. And sample 6 is 1 step up from sample 5, and so on. Across the y-axis, we see the measured value. So we're measuring with the 85, the 60, and the 20-degree angles. And so the measured values are on the y-axis. And then we see the actual graph itself broken off into 3 categories. So we have our low gloss, our semi-gloss, and our high gloss region. And that corresponds to our visual samples. So when looking at the curves, we'll start with the 85-degree curve. So we see that it's fairly straight in the low region to the middle region, and slowly starts to curve as we get toward the higher gloss levels. And so what we can see is that for our 85-degree angle in this low section of gloss, for our samples, say 1, 2, 3, 4, and 5, we see that the 85-degree gloss angle has a better resolution for those lower gloss values. Whereas if we were to take measured values from the 60-degree or even the 20-degree, we see that there's almost no variation as we go across those samples. So what this shows is that for particularly low gloss samples that are typically less than 10 units, it's better to use an 85-degree angle because you get a more accurate depiction of what you're seeing visually versus if you were to use a 60 or a 20. Now, the same is true if we go to a semi-gloss, where we see now that the 60-degree angle has a better performance compared to the 85 and the 20. For example, if we're looking at samples 7 and 8, we see if we were to use the 85-degree angle, that would correspond to sample 7 being around, let's say, 81 gloss units, and sample 8 being around 90 gloss units. Whereas if we looked at the visual samples, it appears like a semi-gloss. And with the 60-degree angle, we're getting a measured value of around 40 units. And then for sample 8, we're getting a measured value around 55 units. So it's a significant difference, and that would correlate better to what we're seeing visually. And then on the high end of gloss, we have 20 degrees. And we see that both 85 and 60 kind of round off towards the top. And so we're not getting as much resolution out of them at those higher values. And so we see that the 20-degree angle starts to outperform both the 60 and 85 at those very high gloss levels. And so with that, there's a rule of thumb in the industry, which means if you take your 60-degree angle and you take measurements and you're getting around 10 to 70 units with your 60-degree angle, then it's recommended to use your 60-degree angle as your main measurement angle for all of those samples. Whereas if you're getting value above 70 units with the 60-degree gloss meter, then you should be using the 20-degree geometry. So that's just the rule of thumb to follow. And then lastly, with the low gloss, anything under 10 units when measured with the 60-degree gloss meter, it's recommended to use the 85-degree geometry. That way you're getting the best and most accurate data when you're measuring different surfaces. So I also wanted to touch on the actual gloss unit scale and what that means. So with all of our gloss meters, they come with our calibrated black glass standards. With this standard, it's set somewhere around 100 gloss units, and we use a special black glass that has a refractive index of 1.567, and that refractive index is exactly equal to 100 gloss units. So what that basically means is if you were to measure different materials, say a plastic versus a metal, you would find that because of the refractive index of that material, you're going to get different results because the light goes and absorbs into that material. The say high refractive index material gets absorbed into and you lose a lot of light versus if you had something like a metal where almost no light gets absorbed, you have a lot more reflection. And we'll touch on that later. Here's a nice graph that shows you how refractive index compares to your different angles and your different measurements and how that comes to be. But we see at 1.567, which is what the black glass standard is set at, we have 100 gloss units for 20 degrees, 100 gloss units for 60, and 100 for 85. So this was determined to be the best type of material to use for that specific standard to give you the scale from 0 to 100. So based off of the refractive index, you can run into some issues where you have such cases like this. So basically what's going on is we have a 2K clear coat system and a 1K clear coat system. They both are visually exactly the same, so they look to be the same gloss level. But when we go to measure them, we find that our 2K clear coat has a lot lower gloss value than our 1K clear coat. And the reason is because they have a different refractive index. So our 2K clear coat is around a 1.5, whereas our 1K is around a 1.53. And because of this difference, it means that we're having a different absorption factor that's occurring in one of these samples. And so when we measure them, even though they visually look the same, because they have a different refractive index in the material, we're going to end up with different results because not all the light is able to bounce off of the sample like the 1K clear coat. And so this is a great representation of why it's important to measure similar samples to one another for comparison. So you wouldn't, in this case, want to compare your 2K clear coat to your 1K clear coat because they have a different refractive index, and therefore you're going to get different values no matter what. So it's always best to, when evaluating samples, to compare apples to apples. So in this case, your 1K to your 1K and your 2K to your 2K. And that's just based off of the material. So here at Bic Gardner, we have our micro tri-gloss. This is one of our more popular gloss meters because it includes 3 angles. So you have your 20, your 60, and 85 all in one unit. And you have the ability to change between viewing all 3 angles or just 2 angles or just one if need be. With these instruments, they're always in compliance with international standards. So they'll always be compliant with whatever spec you're following. We have the expanded measurement range, so you can measure anything from a matte surface all the way to a mirror-like surface. And that expanded measurement range kind of goes into more of what I was speaking on earlier with the idea of if you were to measure something like a metal that has a very low refractive index, you're going to get a lot higher values than 100 gloss units. And again, that's just due to the material itself. All right, so why is it important, again, to use different angles for different types of things? So here is a great example of a weathering test that was done. And so we have two panels here. We have panel A and panel B. The green and the purple represent the measurements taken with a 60-degree angle, and the red and blue represent measurements taken at 20 degrees. And then again, we see that we start, and then we have a 100-hour measurement, we have a 200-hour measurement, and a 250-hour measurement. So if we look strictly at the 60-degree data, we see that both samples start off at the same spot. And then we see at 100 hours in, they're still remaining at the same spot. So they visually might look different, but in this case, their measured values are exactly the same. And then after 200 hours, they're still exactly the same. And after 250 hours, that's when you can start to see this difference in how they're appearing. Now, when we look at the 20-degree data, we see that they start off different already. And so visually, that would correlate better because we're in this higher gloss section or region of the scale. Then after 100 hours, they start to look similar. And after 200 hours, they start to separate again. So they visually look different and they're being measured differently. And then after 250 hours, we start to see this big difference in their gloss levels. So it's always important, if you're, especially during weathering tests, to measure at these different angles because it's going to give you different data that could then correlate better to your visual, depending on where you are on that gloss scale. Okay, so going back into the refractive index. So to separate it completely, you can separate it into two categories. So you can think of something like a non-metal, so a paint or a plastic, and then a metal surface like aluminum or brushed metal. And so what we have is all of the non-metal material is based off of that initial refractive index, so that initial gloss scale. And because of its ability to absorb light and refract light, truly at 20 degrees, we're not getting 100% of light back towards our sensor. We're only getting a maximum of 5% reflectance back towards that sensor. Now at 60 degrees, that changes. And now we're only getting a maximum of 10% back towards the sensor. And then 85, we're getting a maximum of 65% back towards the sensor. Now each of these relate to our gloss scale again. So 0 would be 0. And then in the case of 60 degrees, 100 would be that 10% of light that gets reached back towards the sensor. Now, if we had a surface like a metal, which doesn't absorb light at all, and so it refracts or reflects 100% of light, we see that at the 20-degree angle, we have a maximum reflection of 100% of light, and same with the 60 and the 85. But our gloss units are decreasing. And so for 20 degrees, we have a maximum of 200 or 2,000 gloss units. That's because you're in the higher gloss surface region. And then at 60 degrees, we have a maximum of 1,000 gloss units. And then at 85, we have a maximum of 160. So let's talk about some shortcomings of a gloss measurement. So one of the issues that you might face or you might come across is measuring gloss on a curved surface. So ideally, when you measure gloss, you want to measure on a flat surface. And this is because all of that light will be able to hit the surface and reflect back at the opposite angle and then go right back towards the detector as intended. However, if you had a curved surface, now you add in another variable. So as that light comes down and hits the surface, instead of now getting reflected back towards the sensor, we're getting reflected in different directions due to that curvature. Now what you'll find is you can't necessarily measure absolutes. It's near impossible, or it might be impossible. But what you can do is you can do comparative measurements. And it's best to do this if you set up some type of jig or some type of system to where you can always keep the gloss meter in the same location on the same spot. That way you're always measuring the same defined conditions every time. And with that, again, you can't get absolute data and know your absolute gloss value, but you can do comparative measurements. So, an example of that would be if I wanted between a 50 and 60% gloss value for some type of part I was making, but it was curved. What I could do is create a jig to where the gloss meter is in the same spot every time on the part. And I can take my measurements, and I may not get 50 or 60% gloss. But what I may end up finding is that because of the curvature, I'm able to get around 20 gloss units. And then I can make that 20 the standard, so that whenever I compare parts to parts, I'm always going to look for 20 as a standard, because I know that's visually what I want, but numerically I'm not able to get there because of the curvature. So there are ways around it, and that's one of the methods of doing so. Another shortcoming or issue is measuring transparent materials. So again, just like curvature, you can't necessarily obtain absolute values, but you can do comparative measurements. And so you just need to define all your variables. So in this case, you need to define your sample thickness. You only want to measure samples with the same thickness to one another, because that thickness plays a role. Because now not only do you have light reflecting off the surface of the object, but because it's transparent, we have light reflecting off the bottom of that surface of that object. And we also have light that gets scattered and absorbed into the material. So there's a lot of different variables playing on the light. And so we want to make sure that our sample thickness is the same, but because we also have this light that hits the background and gets reflected back towards the sensor, we want to use something, typically it's recommended to use a matte black background. And this is because you want the least amount of influence from that background. And so a matte black background would almost make it to where zero light would reflect from that background surface. So you're basically only getting the reflection from the initial surface of the sample. So that's one of the ways to combat that. And so with that, that concludes our short presentation today. So if you have any questions, just feel free to put it in the chat, and I'll give it back to you.
Sorry about the typo in your email address there. It should be Noah Morgan. I'll put it in the chat. If anyone has any questions after the fact, feel free to email Noah, not Moa. Anyway, thank you, Noah. Appreciate the time and expertise. Now some questions. I think you hit on, the last couple slides, you hit on a couple questions. I'll read the questions. What are some best practices for ensuring consistent and accurate gloss measurements across different batches or production runs? And then also how gloss measurement technology deals with 3D surfaces or curved objects. And if I heard you correctly, it's that comparative measurements that you outlined just right at the end of the presentation. Is that correct?
Absolutely. So, whenever you're doing any type of comparative measurement, you always want to make sure that everything is exactly the same. The only thing that's changing is your sample. So, whether that may be creating a special jig to hold the instrument on to measure the same spot, or just having guidelines or procedures set to where you're always measuring that same spot in the same way. The both are important, and it's always recommended to have procedures in place. So, things don't happen to where measurements could be taken in a different way, and then the data starts changing, and that's when questions get asked.
Gotcha. Wonderful. Okay. Can you discuss the relationship between gloss and other surface properties, such as color perception or distinctness of image?
Yeah, sure thing. So I'll go back over here. So
All right.
again, with any type of object, whenever light hits that surface, there's a lot of things that are going on. And so, what we see here are we see a diffused reflection, which gives us that color. We see the absorption inside the sample. So you can think of all of these irregular shapes as pigments. And as this light comes through, those are selective pigments, so they're only going to absorb the light or the colors that aren't what this object are. And so in this case, it would absorb orange, green, light blue, purple, everything except for this dark blue color. And then these selective pigments are going to scatter and reflect this light blue color. And so that then becomes a diffused reflection. And so, visually, we would see this object as a dark blue object. And then all of the white light gets reflected off the surface in this case, and that is our spectral reflection or our gloss. So we have just pure white light as our gloss. And depending on how glossy it is, we could have a very glossy surface. And our very glossy surface is going to typically give us a very nice reflected image, sort of related to distinctness of image. There's a lot of other variables at play there. You then have, waviness of the surface, graininess of the surface. But, to simple it down, gloss is a pretty simple measurement. And so we're just looking at how much light's able to completely reflect from off that surface into our eyes, if that makes sense. And then on the contrary, if you had a very dull surface or very matte surface, you have all these micro textures that are at play. And so when the light hits the surface, that light's being scattered in many different directions, but most of the light is still going to come back towards the observer at that opposite angle where the light came from. But you'll see a very blurry reflected image, if that makes sense.
Yeah, totally. Okay, next question here. How do temperature and humidity affect gloss during application? And just to follow up on that too, what precautions can be taken to minimize those effects?
Yeah, so temperature and humidity, I don't know if they would really affect the gloss of the surface unless the surface wasn't completely dry, or if there was some type of reaction in the surface that would react with the temperature humidity. But with instrumentation, inherently with all type of electronics, the heat plays a role.
Yeah.
And so if you were to take something like a gloss instrument and measure a surface that just came out of an oven, that heat is going to affect the electronics internally, and therefore it's going to throw some of your data off. So it's really recommended to not, place an instrument of any kind on a very hot surface. Typically you let it cool down to room temperature and then measure. And I would say, to keep everything consistent and to, for best practices, to keep it or to not measure until you have a room temperature surface that's not going to affect the values inside of the instrument itself.
Okay, good. Okay, you ready for some more questions there? They keep coming in. Sure. This is awesome. Let's see. How does film build affect gloss readings?
Yes. So film build, just like we spoke on before, you have refractive index. And so as you add these different layers in, depending on how or what that material is made out of, those different coatings that you have, you're going to eventually have different refractive indexes. And so that light's going to absorb into the material differently. Mm-hmm. the best recommendation I would have in such cases, if you're doing comparative measurements on um, objects with a lot of film build, is to really measure and compare similar samples to one another.
Okay.
So, again, I'll bring in the 1K and 2K clear coat systems. So if you have a 1K versus a 2K, you really don't want to compare them to one another. And that's because you're going to get different measured values versus what you're seeing. And that's strictly just due to the refractive index, because the 1K system is going to absorb a lot less light. And so you're going to have more light coming back towards the sensor, whereas the 2K system is going to absorb more light. And so you're going to have less light coming back towards the sensor in the instrument.
Okay. Yeah, makes sense. Makes sense. Continuing on here. When measuring gloss on plastic, does the temperature of the sample play a role in repeatability?
Yes. So again, just like the original question, or the one that came earlier,
Yeah.
The temperature doesn't necessarily play a role in the gloss, but it'll play a role in the instrument's ability to measure. So it's not typically recommended to measure, again, very hot samples, because you might get a different value versus when you measured the hot sample versus when it's cooled off and you measure it again. And that's due to the heat affecting electronics. And that's, not in particular to gloss meters, but that goes for really any type of electronic. An example would be if you took a scale and you put, a hot piece of metal on the scale is going to go up and down. It's going to fluctuate, go all over the place. But if you took that same piece of metal when it was cooled down to room temperature and you put that on the scale, it would get exactly what that piece of metal would weigh. So that's a good example of that.
Yeah, definitely. Definitely. Okay, next one here. Thanks so much for the presentation. Very informative. You're welcome. Question. Have you encountered cases where the instrument does not report the gloss value, but did report it in other samples? Should I assume that the value there is 100? This is for when evaluating gloss 60.
That I don't know. So, really all the gloss meter does is it sends light from one side, and then it picks up how much light was, or it tells you how much light was then reflected and picked up by the detector on the other side.
Okay.
I don't know of many cases where it would give you no value, unless, there's something wrong with it, the instrument itself. But typically it should give you a value. Now, you mentioned the, above 100 gloss units. That's only the case if you had something of, very different from your other samples. So again, if you had plastic samples and then you brought in a metal sample, obviously the metal can't absorb light, so it's going to reflect a lot more light. So you'll get values over 100. That could be a case. But for the most part, you don't necessarily see any point where the gloss meter won't give you a value at all.
Okay. Okay. And just as an offer, if you'd like Noah or any of our technicians to test any samples, please get in touch with him. I put his correct email address in the chat here, and he can run some tests to figure out what's going on and to help you out there. So keep that in mind. Let's see. Next question. My company produces packaging film, often for the food industry. When measuring gloss, we typically measure on a transparent film that's 3 mil thick or less. Do you have any recommendations?
Yes, I would say, try to keep the thicknesses the same. That way you're always getting good comparisons between the samples. But the most important thing is what color is your background and what is your background.
Yeah.
Typically, and this goes for color as well, whenever you try to evaluate films or anything transparent, you're inherently going to have the light that passes through the sample and then reflects whatever is underneath the sample. So I would just recommend using, some type of matte black background and then keeping that the same consistently. So you're always going to be measuring against that matte black background, because that'll put the least amount of influence of the background on that measurement.
Yeah. Keeping consistent is, I think number one, not only with the gloss meters, but also all of our instrumentation. If you're measuring consistently the same way, holding the instrument in the same direction every single time, you're going to get that apples to apples comparison.
It's the name of the game.
Yeah, you got it. I think we bring that up every presentation, but it's that important. So we're going to continue to bring it up. Next question. Can we measure haze? I heard there was a haze meter, but no longer offered by BIC.
Yes, we do still offer that instrument. So a couple different methods for measuring haze. There's measuring reflected haze. So in the case of a sample like this, typically done on, brushed metals, where you're looking at how good is that image forming quality. So unlike the gloss meter that just measures how much light is reflecting off the surface to give us a gloss value, we have what's called a haze meter that can measure the image forming qualities. How hazy is the reflected image of that surface?
Are you talking the haze gloss meter?
Yes, the haze gloss meter. Thanks for the correction. So that would give you, that would be good for samples like this. But we also have something called the haze guard, or the haze guard eye, which measures transparent films. And so that's measuring how much light can pass through, completely pass through an object and get picked up on the other side. So two different types of instruments. It'd be worth reaching out to, one of us to see, what your application is and how one of these instruments can help you best. So I'd recommend just reaching out to one of us and getting a hold of us.
Yeah, I did put links for both of those instruments in the chat, but also any of the marketing automated messages you get from us, you can simply hit reply. It'll come to my team, and we'll funnel it to Noah or the technical specialist in your area. No problem at all. Let's see. Can you elaborate on what's the cause for when some samples do detect values and other samples don't? I think this is a bit of a repeat.
Yes. So, I think I've spoke on it earlier. Typically, it shouldn't give you, you shouldn't have a result that isn't anything, right? Because with the instrument, I'll pull up this, what we're basically doing when the internals of this is just measuring the light that goes from here, which is 100% of light. It hits the surface, and then this picks up, all the light that gets reflected back. It could be a case where there's zero loss. That could be if there's no sample reflecting any light back. So if you just held it up in the air and took a measurement, that would be a case where that happens. But typically, you're always going to get some type of value if you have a sample underneath of there.
Awesome. And again, too, Noah and his team's available for testing and just running some trials for you to see what's going on. How often should gloss meters be calibrated?
Yes, great question. So our lab here is ISO 17025 certified. And so with that certification, we can't necessarily, decide for you how often to get your gloss meter calibrated. It's entirely up to you and your company, whether you follow internal policies or specs that tell you need to get your instrument certified, ever so often. Typically, we recommend, anywhere from 1 to 5 years. 1 year is for somebody that uses it almost every day. It gets exposed to a lot of harsh conditions. And then if you find that, after 1 year that, you could go further, then you could expand it to every 2 years or every 3 years. It's really entirely up to you and whatever your process is, because, a lot of industries use equipment differently. So it's kind of custom for each person, if that makes sense.
Yeah. Yeah. Rolling right along here. In your experience, how does gloss impact color measurements using multi-angle spectrophotometers?
Yes, great question. So gloss has a very big role on what a color is. Um, it's not in this presentation, but in some of our color presentations, we also go over how gloss plays a role, mainly due to the structure. So typically, a matte surface has very low gloss. And what you can think of happening in a matte surface is a lot of microtexture. Because of that microtexture, colors might seem a little dull, versus if you had a high gloss surface, you would say that the colors look very brilliant, very bright. So really, gloss is one part of a multi-part process to figure out what the color is, if that makes sense. I would say gloss has a very big role on color evaluation.
Yeah, definitely. Okay, combining a couple questions into one here. Is the black matte background the best color? Is white not recommended due to the reflectance and brightness? Is this black material paper or something else? And where can we purchase it?
Yes, great questions. So black or matte black is the recommended background, and that is, to answer your second question, that is due to the zero reflectance that it has. You wouldn't want to use a white background because the white would introduce reflectance that would alter your data.
Yeah.
So you want to use something that will have the least amount of effect on your measured values. So that would be your matte black background. Typically, we find that a felt is a black felt is the best type of material for that, because of all its microtexture on it. It doesn't reflect any light. Where you can get that, off the top of my head, I don't know. But you could reach out to one of us and we could look at some options for you. We also recommend doing a Google search of where to get black felt. But I think that is one of the best materials for especially this type of measurement, for transparent materials.
Yeah. Yeah. I got messaged by one of my colleagues here too that there used to be a micro haze, and that might be what you're referring to there. But I haven't heard of anything new coming out. But I can do some checking and mention it in the next webinar if I find some information of something in development or something coming down the road. So stay tuned on that. Back to questions here. Is the haze guard effective for measuring glass haze on glass windows?
Absolutely. So that's what it was mainly designed for. So it has 3 different measurements that it can do. It starts. First one is a transmission measurement, so light transmission, how much light's able to pass through that object. The second measurement is haze, so it can measure how much haze is in that product and that glass. And the last measurement is clarity, so how much clarity is in that material. These are 3 different measurements, and then on our website, John, I might send the link to you so you can drop it in there. But
sure.
There's a nice PDF document that we have that goes over what is clarity, why is clarity a measurement. It goes to the whole background of clarity, haze, and light transmission, and what each of those values mean and what they look like visually, to help you fully understand how that instrument works and what all it does. It's a great resource I would recommend.
Okay. More information on the micro haze. It was a handheld reflectance haze meter that looked just like a gloss meter. So now, that is evolved into the haze gloss. That first link I just sent you. So good. It's good having multiple people on the call here who know way more than I do. So that's a good thing. Let's see next. Any correlation between the haze gloss meter and the haze guard technique? Example, if samples show higher haze in in the haze guard, do I expect the same trend to continue in the haze gloss meter to have those higher values?
So that's a great question. There's a lot of variables at play that affect the haze. So it could be something, it could be something where the surface is very uneven, so that could be affecting the haze. It could be that there's a lot of, let's say, imperfections inside of the material that's causing the haze, or it could be on the back end of that material, the bottom surface that's causing the haze. So it's hard to say really if there's, a link between the two, just based off of where the effect is coming from. But typically, if you have something with, in this case, you'd say an uneven surface that's causing the initial haze, and then you have some internal scattering effects that are causing some haze. You could find a link between that and say how matte of a surface that is. But you got to remember, you're measuring two different visual things. So, you have your gloss, which is typically a surface measurement, and then you have haze, which is typically, it's also a surface measurement, but it's looking at some other things at play. So I wouldn't say they're directly comparable, but you could find some link, between some like samples.
Okay. Can gloss have a negative value?
It could. Don't know if it can, and that's just due to the basic principle behind it. Like again, it's you have 100% of light that you send to a surface, and then it gets reflected back towards the other detector.
Okay.
I don't know if that would be possible just based off of that principle.
Yeah.
I would say I've never seen it before. But that's a good question.
Yeah, we can look into that and see if that's possible. Let's see here. Good round of questions, folks. We got some time left, so if you have anything else, keep it coming. Let's see. How does the human perception of gloss differ from instrumental measurements? And what challenges does this present for quality control?
Yes, so the human perception of gloss. So I'll say that the human perception of gloss is, we roughly base these values or the instrumentation off of our visual perception. And so you can find a clear link. Let me go to this slide here. So using this rule of thumb, you can then take measurements, with the instrument, and it will always give you almost exactly what your visual perception is, using this rule of thumb, of course. But you got to remember that the instrumentation is really designed to give us the numerical values that our eyes are showing us. So the inherent design behind the instrument is to give us this correlation between visual and numerical values.
Okay, good. Another one here. How do factors like surface texture, transparency, and substrate affect gloss readings? And how can we account for these variables? And I know you touched on this before, but maybe just hit it again.
Yeah, so surface texture can affect it, because if you have a lot of surface texture, that means you're going to have a lot of light scattering effect. So, like I mentioned before, a matte surface is really a surface that just has a lot of micro texture. And then a glossy surface is just a surface that's completely smooth. So if you have a lot of texture on that surface, you're going to have a lot of light scattering, and you're going to have a pretty matte surface. Can you repeat the question again?
Yeah. How do factors like surface texture, transparency, and substrate affect gloss readings? And how do we account for these variables?
Yes. Okay. So your transparency, if you had a transparent sample, let me bring this up again. So your transparency affects it in that you're going to have light that now not only reflects off the surface, but now you have some light that's getting absorbed into the material, and you're also having some light being reflected off the background. And so now your background is at play. So really, all of these have effects that you're going to see, and you're going to also see in the numbers. A way to, make it to where you can have clear comparative measurements is, again, if you keep everything the same except for your sample. And so what that means is you compare samples that have the same thicknesses. So you don't want to measure a sample that, say, has a thickness of 1 inch versus a sample that has a thickness of a 1/2 inch, because you're going to get different results, even if it has the same visual gloss appearance. And then with the background, you want to make sure you have the same background, because your background is going to play an effect, because if it's a transparent material, that light's going to also go through that transparent material and reflect back towards the sensor. So you really want to compare like samples to one another, if that makes sense.
Yep. More questions, folks. I know we're running out of time here, but we have just a couple minutes left. One just came in. Thank you. When a sample has poor chemical resistance, the gloss value should drop, right?
That I do not know. I would imagine, there's a lot of variables at play in that case. I will say I don't have much experience with chemical resistance and surfaces, but I'd be happy to research that and look into it for you, if that's something.
Yeah, do some testing. Yeah, shoot Noah, noah.morgan@altana.com a note about that, and he'll get back with you. Any final thoughts, Noah, or tips that bring this full circle, for people looking at measuring gloss and using it in their day-to-day?
Yes. So, remember, we went through this presentation, but the idea of a gloss measurement is very simple. Again, you're just sending light on the sample and then recording how much light is reflected from that surface to get your gloss value. So I wouldn't say overthink it. Just go back to the basics. It's just a simple measurement. And then always, if you have different effects like curvature, or you have transparent materials, there's some things that you can do to make it easier on yourself in the long run. And that would be just measure like samples and compare like samples. In the case of curvature, you always want to make sure that you're measuring the same location in the same way. Utilizing a 3D printer to make a special stand for your specific parts is always a great idea that we encourage. We have a lot of customers that have done such things in their own manufacturing processes. So that's a great way to keep things consistent. And really, with any type of measurement, the only thing that you want to change from sample to sample is your sample. With that, you always want to keep everything consistent, keep everything the same, except for changing out the samples that you're measuring.
Excellent. And we did have one more question sneak in here. If you got another minute there, Noah.
Yep.
Can you go back to the measuring plastic transparent film that is perhaps printed in the same areas with different colors with process versus line inks?
Can you repeat the question again?
Can you go back to measuring plastic transparent film that is perhaps printed in the same areas with different colors with process versus line inks?
Okay. So if I get the question right, you're saying if you had something like a plastic transparent film that also had some color in it as well, versus an ink.
Yes.
So I would say, if it is truly transparent and you can see through the material, it'd be ideal in that case, because the light's going to be passing through it in the same way you can see through it. So you should really try to use a matte black background. Even, if it's transparent enough to see through, I would say a background is key to consistency. Again, same with the thickness there. If you find that it's become opaque due to the color properties of it, you might be able to get away with not using a background because the light isn't able to penetrate through the color of that film. So, you really can't go wrong with using a background, because either way, if the light's able to pass through or not, it won't play a role in that measurement. So, when in doubt, using a matte black background is a good way to start out.
Yeah, good advice. Good advice. All right, thank you, Noah. Appreciate your time and expertise as always. You're always teaching me something. Thank you, everybody, for attending. If you have any questions, you can hit reply to any of the marketing messages you get from us, and we can funnel it to the right people. We appreciate your time. And again, you'll get the link to the recording, and hope you learned something as well. Have a great rest of your day, and we look forward to seeing you on future Bit Gardener webinars. Thanks, everyone.
Take care.